Understand that we need to define continuous motion using limits. X approaches A, right? Somebody, what do you mean by X approaches A? You have to use a motion. And how did we break that? Using actually Xn approaches A. In that way, you don't have a continuous motion. Now, if we have to think about continuous motion, now you have this limit defined without using continuous motion. How do you explain continuous motion, right? From there, you will see mathematical definition of continuity. And probably in the test one, and you'll be asked to state the mathematical definition of continuity. It has to be verbatim that internationally acceptable mathematical definition of continuity. Is not like paraphrasing and the meaning, something that you found in somewhere in the internet. It has to be that particular. That's what the second part means. All right? Okay, move on. So, big question. What is continuous motion? All right. There we go. It's bullet. Fire upward. It's going to come down. I saw this video. It actually comes down. All right. So I'm describing linear motion. It goes up and coming back down. Okay. So this is how we're going to bring in the continuity. This horizontal axis is not X. The horizontal axis is going to be called T. Why is it called T? It's time, right? So its actual spatial movement is going up and down. It's boring, right? But you have this time axis and its motion is expanded over time axis. And the official name for this one is whatever kind of space-time, right? Here's a space and here's a time. Now at the beginning it was here, right? You blink your eye and whatever the measurement you have, you measure the next moment. That's not the same as it's continuously moving. It doesn't matter how close it is the next moment there, right? Split second later, where was it? It was up where something there, right? Correct? Measurement. It could be millionth second. It could be whatever the small period of time, but it is not continuous. Next moment, it's here. Next moment, it's there, right? This is all we can comprehend. But you believe it was there in between, right? It was there in between. So you believe that it's actually looked like this. Whatever the position, there's this infinite many dots. There's no hole in there. Okay? So you believe it moves continuously like that. So if I sketch it like this, there's no hole in between. It's a continuous. And we want to define it, not using no hole kind of thing. All right? So the next thing, so that's the space-time. So we say if whatever the definition of this graph being continuous, then we say the motion is continuous. It's motion in the graph in the space-time. If that graph is continuous, we say the motion is continuous. So here's an example of discontinuous motion. This was first in physics discovered by radiation of a black body. The energy level, like temperature. Do you believe the temperature is continuous? There's no skipping of this moment it was a 30 degree and split second next moment is a 35 degree. You don't believe that. You believe that even though we didn't measure it, it passes 31, it passes 31.25, passes, move up to 35, right? But strange thing happened and physicists believe that there is no middle zone. You have 30 and 35 degree in terms of energy level. Energy, very abstract, is hard. So I created this ghost particle. It could be photon, it could be electron. So I'm going to pretend that it actually happens like this. Here's a position of a photon, and here's a time. So graph turns out to be like this, if it's a space-time. So how would you describe this motion? Continuous, very nice. Anything else? Being this is horizontal, what's that? Linear? If you actually see this particle, you wouldn't say it's linear. You only say linear because it's in space-time, right? If you're actually staring at this electron with electron glass, you wouldn't say it's linear. You will say that's not moving. That's the word that come out of your mouth, right? At t various time, the position never changes. Always the same position. Is that right? Yes. Fair enough? And then this next moment, let's say it was a 3 second, this guy's here. How would you describe this motion? It was there up until 3 seconds, right? Boom, disappeared. It appeared somewhere up there, right? That's the motion. Would you say this is a continuous motion? So graph is, there's a break. The word is a break, right? The break. How about this one? It looks like continuous, but they measured it closer and closer to the phenomenon at 3 point, zoomed into the 2.9 whatever the millionth second and all, and then they realized that, man, that guy was up there. One moment it came down in here. You examine the video, that guy was there, boom, it came back down. Do you see that? Yeah, it was there, blink of an eye, it appeared there and came back down. That's the motion. Would you say is it continuous motion? It's discontinuous motion. If the graph has this break hole, things like that, that is the intuition and idea. All right. We have learned so far close to 2 weeks. Learn about what? Limits. So we're gonna use the limits to describe what's happening at 3, right? We're gonna use that. So what would you do? First we consider what? Let's say that was a function of y equals ft. Is that okay? Yeah. We're gonna consider limit. Limit, right? What's the letter underneath it? X is the wrong letter. What was the correct letter? T, thank you. T approaches what? 3, thank you. F of T. Right. Everybody understand what this one is, right? This one is talking about where was it right before 3 seconds, right? Where is it right after 3 seconds, right? How about this guy, f of 3? Where was it at 3 seconds, right? Are they the same for this ghostly particle? They're not the same. What do you say? Discontinuous. How about this bullet? You believe it was always expected the place you expect to be, right? Is that right? So you believe this is continuous, but no one really knows. But come on, that's ridiculous. It was there, right? So we believe it's a continuous. But here, physics is happening. It's not continuous. If you zoom in, they're puzzled. Einstein hated it. All right. Let's write that down. So what is it? What is the continuity? This is a continuity. You have to accept it. Again, write that down. If you're asked to state the definition of a continuity, if you talk about bullet and ghost particle, you get 0. You have to write this one down, right? These 2 items. Yes, ma'am. That's right. This is a verbatim. You have to copy it down. This 1 and 2, right there in the test.